Here we are, episode 678 of Josh Tries to Cut a Spiral Groove. You'll remember from episode 1, this was a standard Harbor Freight lathe, but it's gone through a couple of changes since then. So I'm going to walk you through what I've done and what I'm going to try and do today. So first thing to go was the tool post. I can still attach that, that's how I indicate things, but I replace it with a mill. First thing I tried was a Dremel, but the Dremel had too much run out and too much flex at the tip, so I got a spindle. I've got that controlled and that's mounted here. That allows me to do my cutting. The next thing to change was I'm trying to cut a 1 thread per inch groove, and so I had to drive from the lead stock to get the headstock to move, or lead screw, sorry, to get the headstock to move, because the gear ratio was such that back here that if I was trying to drive from the headstock, these gears would bind. It was way too much torque. And it didn't work. So started driving from down here. I was driving down from down here by hand, then using a little power drill, but I wasn't getting consistent torque. So I built a little attachment post here that connects through with a set screw and connects me through to a stepper motor here. It's mounted on a little bit of aluminium framing stuff to get it up to the right size, and that then drives that. So I was able to drive the lead screw, have the headstock move using the gears, and make my cut. But the problem was I was getting a lot of backlash on the gears here, particularly the reverse forward lever. And so as I was trying to diagnose that problem, I realized probably the best thing to do would be to remove the motor, the servo motor with a stepper motor, and just directly drive, without the gears, directly drive the headstock independently of the lead screw. That way I can move things independently. That lets me cut with torque and not worry about as much backlash, but it also importantly lets me cut non-linear grooves here, as these guys need to move independently from each other. So that's great. Got that all working, got that all sort of set up. I've got a few issues with it, but it seems to be good, and I seem to be ready to mill, whatever this is, cylindrical milling. This piece here. So what I've got going back here is I've got the drivers for the stepper motors, power supply, just a little Arduino matching board thing. I've written some software that lets me zero and set directions and do all that sort of stuff and control. There's a few bugs there when it comes to timing, but everything seems to work okay. I was trying to be a little too clever with the code, and I was looking for like the greatest common denominator in the duty cycle times between whatever to make sure that things whatever, but in that I made a mistake, so it's running a little slower than it should, but that's okay. Anyway, so I've cut off a piece of brass. I want to, you can see, I've got it engaged, but my cut is not straight at all. I just cut it off with a hacksaw. I really need a bandsaw or something to get better cuts, but I've got like a 1/4 inch of run out there, so I'm going to mill that off using this guy. And that'll be my first sort of milling operation, facing operation with this weird hybrid lathe mill setup. Anyway, enough talking. So what do I need to do? I need to remember something. Yes, I need to remember that my actual grooves that I want to cut will be with a smaller piece. I've got the 1/8 end mill there, but that's fine for this facing operation. So let's start off. We'll spin up the motor. We'll rotate this guy, the headstock, let's say 20 times, and we'll move in by 20% of an inch, 0.2 of an inch. So move headstock. Which direction do I want it to go? I want it to go counterclockwise, climb milling. I said 20 times. Yeah, 20 times is good. Move the carriage in by 0.2 of an inch. I haven't got a stepper on here, so I don't have my Z-axis. Oh, that guy's not engaged, so that's hard with one hand. There we go. That's engaged, and I want to do it over the course. This is where I've got a bug. It'll say 30 seconds, but it won't actually run over 30 seconds. It'll take longer, but whatever. 30 pseudo seconds, and that's all for naught because I need to turn the mill on first. One sec. So let's turn the mill on. Mill on. Move -20, 0.2, 0, 30, and some cutting fluid. Let's hope this works. Here we go. That worked great, except for 3 things. Thing number 1, I wasn't wearing safety glasses. Problem resolved. Thing number 2, that throws off a lot of chips. Electronics, chips, electronics. Got myself a lovely plastic box. Step number 3, I didn't cut off as much as I needed, so I'm going to go forward. I could measure that, but I'm just facing, so it doesn't need to be super accurate. And we'll go faster on the headstock, so we'll go 50 rotations there. Go crazy, 70 rotations there. That was taking off 0.2 of an inch. We'll go 0.1 of an inch. 0 on there, 30 second, air quotes, 30 seconds runtime. And I've done this thing again. I've forgotten to type in the command to start the motor. I should probably fix that. That just knows. Alright, mill is on, 70 rotations, 0.1 of an inch over 30 pseudoseconds. So I manually interrupted that. It seems to have done the job. Oh, wow, that's a really sharp edge. Let's have a look. Let's disengage. Come out here. That's done a really nice job. Don't know how I do a chamfer on this setup, but let's go chamferless. Alright, I'll be back. I'm going to change this into a 3/16 end mill, and I'm going to try cutting my first spiral groove. Yeah, excited. I've got a 3/16 2-flute end mill mounted up, and while I was doing that I noticed I still have a bit of backlash. The stepper motor is engaged here, but you can see here some of that is coming from the belt. Maybe I need to tighten that up, but even then it's pretty tight. I think most of it's coming from the gears in here that change from high low. I only ever want 1 speed, which is low, so maybe I can fix that later, but hopefully if I'm careful I'll be able to do what I'm about to do. Well, so I'm zeroed here. I've got this end mill backed off a little bit. I want to take about 1 inch in this way over the course of 1 turn. So that should be a relatively easy command. I want to do a total depth of cut of 30 thousandths. I'm going to do it in 10 thousandths at a time because I want to be careful, and I'm going to take it super slow because I've never done this before, and hopefully this will be the finished piece if this works out. So step 1, turn on the mill. Mill is on. Step 2, we want to go 1 inch. We want it to go counterclockwise, so -1 that way. We want it to go in 1 inch, and we want to do it super slow. So I'll probably feed this, fast forward this on YouTube. So here we go. Oh, need to go in a bit. Always have a checklist, which I don't have. That's at 10, it should be at 0. Let's go in. Did you see how much that moved? I think maybe I forgot to tighten up some of the carriage when I put this guy back together. Oh well. Here goes nothing. Yeah, that's a problem. I forgot to engage the half nut. It's hard to do one-handed. There we go, half nut. Alright, half nut, 10,000. I'm backed off, so I should eat up the backlash. M minus 1, 1, 0, that. It's going. It's just going super slow. Okay, that took a while, but I'm back. Let's turn the mill off and take a look. So I'm wearing headphones, not headphones, earplugs now. So I'm probably yelling. Okay, yeah, we started a little bit further back from the start. So back here, that's why these guys don't line up. That makes sense. I'm going to back out 20,000th. I took a 10,000 cut, so that should be plenty of room to run the next command, which is, well, let's do the same thing we just did, but let's do it backwards to end up back where we started command. Otherwise known as reverse. I've got a version that runs slightly faster, so I'll run that rapid reverse, but given that the first one was so slow, it's still going to be pretty slow. But hopefully we end up back in the same spot. Fingers crossed. Of course, this will take a while, so it's still faster, but not that much faster. Alright, let's give this a minute or so to come back to the start. Oh yeah, look at that, it's reversing the other way, but it's still reversing. Hopefully we're all good, and I can take the second cut. That'll be the real proof of the repeatability. See you in a sec. Okay, so we are back at the start. I hope that's where the start was. You can see the screw actually starts back here, but it seems to be as far back as we were before, so I assume that's all good. 0 on the compound. We took a 10,000th cut, so I'm going to call that now 0. I'm going to go crazy and take a 15,000th because that seemed to be fine. And the last one, I'll take a finish pass, so to speak. Call another 10,000th. I'm going to do this one a little faster, I hope. Not that much faster. Let's turn the mill on. Let's move, we're going forward 1 inch, back 1 inch, and we'll do it twice as fast as the previous one. Which is still pretty slow. But the proof is, does that guy meet up at the right spot? So I'm reversing the piece now. I've taken my final cut. But I am having some repeatability issues there. If you can see here, it's a little hard in the position that it is right now. But the mill has left 3 distinct tracks. Now they're not off by much. You can see, maybe, let's see if I can clean this up a bit for you. On that side there, on the end, there are 2 tracks. Off by a fraction of a hair, but it's still 2 tracks when there should be 1. So, for my next groove, I'm going to cut it the full depth. I think I can cut 45 thousandths in one pass. It shouldn't be a problem. I'm not zeroed though now, and do I want to do this by hand, or do I want to do it with the computer? It's a big thing. It's a bit of a switch over from operating a lathe manually to having one where you've got a computer control things where you just go boop, touch off and whatever. I'd lose my zero when I don't have the stepper motors going. I should have some sort of DRO type setup thing happening here, but I'm going to touch off virtually. It's probably a really bad decision. I should have kept track of how far I pulled that out. Does that look like zero to you? Yeah. Who knows? I guess the depth isn't super critical, so I'm going to call that 0. Yeah. Alright, so what I want to do now is rotate the headstock by 1/3, so 120 degrees. So I should be able to do that programmatically. There is, I know, a bit of backlash in the headstock. Why is that not focusing? Anyway, whatever. Some backlash in the headstock. Move headstock by 0.33333. Neither other directions, and we'll do it over the course of a few seconds. Alright, so that should be the second start of my second thread. That should be 120 degrees if my math is correct, and it not always is. I'm going to go in 45,000th, take a full depth of cut, 20, 30, 45. That's a pretty deep cut. But we'll take it slow and it should be okay, because I did that facing operation and things looked fine, so that should be fine. I don't have a good sense of how much torque I can handle yet. So move forward 1 inch over 1 rotation, and we'll take it super slow. Here we go. Wish me luck. Oh no! No! I was just caught by the didn't start the mill bug. I should have kept the 0 so I can return back to 0. I do have a zeroing function in my program, but I didn't use it. Bum. I'm going to have to align this all up by hand. Line it back to the 0 over there, and okay, back in a sec. So I definitely have the mill turned on this time. I was kind of a little iffy on lining it back up to the start. I've rotated it back to 120 degrees. I'm going to start the cutting operation. One revolution, 1 inch, 0, 0. I guess there's an advantage to writing the code beforehand. It is running it all. Problem is I don't have the Z-axis control, so that's why I'm getting involved, and problem exists between keyboard and computer in this case. I need that Z-axis control so I don't have to touch this thing. Alright, mill's on, programs entered or commands entered. Ain't nothing to it but to hit enter. This will take a while. I'll catch up soon. Let's actually just watch the first bit for the cut, because this is a pretty deep cut. I did back it off a little bit. Just finished cutting the second groove, and it seemed to work out okay. I'm not sure if this is the light, but even with my finger it feels like the edge of this cut is wobbly. I was taking a much deeper cut on this one than the first one, but the first one still has some wobbles along the edge. They're not huge, but they're definitely palpable. Not sure what's doing that. I'll look for some slip either in this guy or the guy at the back. Not sure how that might be backlash, but maybe it is, as gears sort of aren't fully meshed. They wobble with the increase and decrease in torque as it makes its way through. Not sure. Anyway, so I'm not going to make a mistake this time. We're at 25. I'm going to back out to -10 or 30. We're going to do reverse. We'll do the quicker reverse, which is still pretty slow for video. Reverse. Once I finish reversing, I will rotate again by another 120 degrees. And the question is, do I do it in 2 passes or 1 pass? Definitely looks like the 2-pass one is more wibbly wobbly. But the 1-pass one does have the lip on the edge. You know what, I think I can live with the wobbliness of it. Let's see how it feels in its application. I'm going to do a lot of sanding of this piece, because it has to be a slip fit into another piece. I guess I wasn't fully zeroed, because it's picking up a chip. But anyway, that could be just a chip it picked up from the side of the groove. Anyway, this is going to be back here soon. I will go around another 120 degrees. I'll do the same depth of cut, which was 25 thou. We'll move back 30 here. And we'll see how that goes. I have taken my final cut, and I've learned a few things. Firstly is, don't mess up when I'm not zeroed. You can see these are almost 120 degrees apart. You've got two which are nice, and then one that has a slightly fatter gap. I'm guessing that's the one where I moved it manually and lost positioning on my motors. Now, these are an open loop system. I have no feedback. I'm thinking I might take apart a cheap digital caliper and just use that as a DRO. I should be able to just read, I think they're like 4 phase pulses you read off the induction-y guy, and you can get position off of that. But you know, it's a project for later. So that's the first thing I learned is you know, don't mess with the system. Number 2, which is more concerning, is these little wibble wobbles. I've taken out the aforementioned calipers just to get a measurement on them. They seem to be about 16 thousandths, which is quite significant. Probably fine for what I'm trying to do, but it's not great. They're occurring on both sides of the groove, which I guess makes sense. I don't know why that wouldn't be the case. I wonder what's causing that. I'll have to do some thinking. It's not great, but it's probably good enough for this application. So that leads me to the third thing I've learned. CNC control is kind of boring. Once it's all working, well, working in quotes, once it's doing its thing, regardless of whether it's the right thing or the wrong thing, just sit around doing nothing for a while the machine works. I need to come up with better ways to use my spare time, such as cleaning this guy off. These are razor sharp edges, sanding it down, filing off the burrs and sanding it to get a nice fit. I'll try and sand out the groove as well a little bit. That should take a few hours, and that should be a nice mindless task while watching TV or something. Anyway, I think this should hopefully be an interesting video. Love to hear your feedback. Thanks. Bye.